welcome to another episode of My 2 Cent. My name is Paul Emerson, and I'll be giving you my 2 cent. Today's topic is going to be a continuation of the number line, and actually, I guess it's not. I guess today's topic is going to be the My 2 Cent Ruler, because that's pretty much what these objects are. This program is Blender. This is not a Blender tutorial. It's a 3D graphics art application. It's free to use, free to download, and I've used it to make some fairly accurate tools, which I plan on actually manufacturing, producing, and selling as a product in the foreseeable future. What you're looking at is the My 2 Cent Number Line, and basically what the My 2 Cent Number Line is, it's a ruler, same as a regular 12-inch foot, 1 foot ruler, or 30 centimeters, 1 meter stick. And as you can clearly see, the units, as I slowly zoom in, they're subdivided in a certain type of way. So let me explain. Basically, from where is it? I want to get my units right. Okay, so this is roughly 25 centimeters. The whole thing from here to here. I'm sorry, from this number here to this number here is 25 centimeters. From here to here is 2.5 centimeters. 2.5 centimeters. Now, from the distance in between these is divided into 10 subsections. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 subsections. These represent a distance of 0.025 centimeters subdivided by thirds, which gives you quarters of measurements. What this allows you to do is it allows you to, so the metric system uses a standard decimal system, but it's influenced by the American system, and that uses a fraction system. So what this ruler does is it kind of combines both of them in the same. It works as a yardstick. It works as a measuring stick and a scale, because the units of 0 to 10 are the same. From 0 to 0.1 is the same ratio as 0 to 10. So that hopefully that makes sense. But yeah, it's something I was thinking about, something that I thought was going to be necessary for moving forward with My 2 Cent as a scientific discipline. And I really don't know. I guess I should try to, I'm going to explain the way that the units work, or what inspired the units, which is why I kind of made the My 2 Cent precision protractor. Because basically, if you look at the protractor, it's kind of hard because it's so big in the actual 3D program. It's the scale, so as you can see, the numbers just kind of go around 3, keep going 4, and then 5, and they just keep going around 6, 7, with negatives in the center, 8, 9, and 10. And the negative numbers on the opposite side are very counterintuitive for a ruler. It's like, why would you need a net? Why would you ever need to measure anything in units of negative units? But the logic behind it is that this ruler doubles as both a number line for measuring quantities in real space, so these are real numbers, and it's an actual counting instrument. So if you're trying to learn how to count, or if you're struggling with doing math, you can just count the units out. So you know from here to here is 1, and from here to here is 2. So 1 plus 1 equals 2. Like you can clearly see that if I have 1 and I move over to the right of 1, then I have 2. And then you can also counterintuitively understand that if I have 1 and I don't have 1, then I have 0. And you see, okay, so if I add 1, if I have 1 and I don't have 1, then I have 0. So I move to the right. And intuitively, if you move to the right, then you're adding 1. So you kind of intuitively understand that if I have negative 1 and I need to get to 0, then I must add an additional 1. So it's a very intuitive reasoning system. The only way I can get to negative 2 is I have to add negative 1. So I'm subtracting negative 1 to get to 2. So it helps you reason that out really well by just seeing it in a real world application. So if I go back, not here, hey. Oh, I know I did. So if I go back to the My02cent Protractor, you have the same thing. You have, so on my screen, if I move to the right, this is the right. If I move in this direction to the right, if I move in this direction to the left, if I move this way to the right, then I'm going to increase numbers, just like on the linear number line. So from here to here is a increase of numbers. From here to here is a decrease in numbers. If you look at the My02cent Protractor, if you move in a curved linear motion from right down to left up, that makes a circular motion, then the numbers on the number line will increase. So logically they will increase. And if you move in a curved linear motion to the left, then you are describing negative numbers. In the same way that if you move from negative 1 to what would be 0, then you would actually, cause the reason why it's 0 here is because the lowest number, if you have 1.1, negative 1.075, negative 1.05, negative 1.025, then logic dictates that this location here has to be 0. However, because this is a scientific instrument and it's describing a curved structure, if you have negative 9.9 and then you have negative 9.25 and then you have negative 9.5 and then negative 9.975, then logic reasons out that this location must also be negative 10 with respect to 9.9, 9.25, 9.95, and 9.975. Logic dictates that you must add a 1 to this location to make this 10. But you don't want to start a progression system logically with 10. You want to start it logically with 0, so that you go from 0 to 0.2025, 0.05, 0.075 to 0.1. So it's an intuitive thing, whereas here you have to understand the abstraction that there is a negative 0 here, because there's no such thing as a negative 0. You must also intuitively and abstract that there is a positive 10 here. And you can reason that very well by just simply looking at the negative 10. There's no reason to draw a negative 0, but there's a good sound reason, there's sound logic in just having 0 here. So with that understanding, what I would like to explain is, when you move from this point to this point on a curve, we define these locations as arcs. I want to say 100% that these are arcs. So any distance between this point and this point is an arc. A degree, the division of a circumference. So when you have a straight line, like this line here, straight line, it's just called a line. When you define a straight line on a spherical path, we call that a curve. If you have a curve that is continuous and connecting on itself, then we call that a circle. If it's not like allegoric to a square, if the curve is not even or equal on all sides, then you are defining an ellipse. With the My02cent number line, we can say that the distance between these degrees are subdivisions of a known circumference. Since we know what the circumference is, we can define the relationship of these actual degrees. One of the cool things about 3D, and the numbers are not on the actual structure, so when I do this, the numbers themselves won't move, but the object will. You can intuitively see that the distance, I'm going to scale this up, and the distance between these two will actually increase in distance apart. Well, I guess you can't really see it. It would have to be done at a scale too large for my, let me try. First, we need to get a relationship gauge. So we'll use roughly two blender units will give us our gauge. And so I'm going to scale it up a lot larger than it currently is. Go up. Okay. Then I'll zoom back in on it, and then the distance between these 2 points should be reflected in the blender units, because they're set to centimeters, as being more than just 2 blocks of a distance. So originally the 2 gray squares, there was a single line here, and it was like 1 square here and 1 square here. Now the distance between them should be more than just 2 blocks. It should be maybe 3, maybe 4. So yeah, so as you can see, it was like 1 space a block and a second space a block, but now it's 4. So the circumference of this circle has increased, so the distance in relation to these 2 points has also increased. So what this does, so what we have in mathematics is we have the term arc, because an arc is understood to have a changing relationship as you move away from the center. The center point, the closer you are to the center in an arc, the smaller the area or distance between the 2 intersecting lines will be, and the further you are away from an arc, the greater the intersecting points will be between the 2, the greater the distance between the 2 intersecting lines would be. So with that being said, because I scaled this ruler, and it may not be perfectly allegoric to the other number line, but we can assume that the ratio of this protractor is synonymous with the ratio of the number line structure. So their relationships are close to being the same. And what this does is it allows you to understand intuitively the nature of numbers on a curve in much the same way that you can understand the nature of numbers in a linear path. Because a lot of our misunderstanding in physics, astronomy, cosmology, a lot of our misunderstanding in science comes from the fact that scientists abstract natural order with mathematics. So we derive from unseen natural phenomenon using concrete measured experiments. And if you don't have a solid understanding of how the math actually works, then you lose reasoning and understanding of the abstraction from the material world into the formal mathematical constructed an allegoric description of a natural phenomenon. And so with that being said, this ruler helps you understand that. In the same way that I just described that, if you look again, the distance between these 2 points is just 2 blender units. The scale nature of this